Hello again. Today we're going to be solving systems of equations in 3 variables. The variables we're going to be dealing with today are x, y, and z. So what we're going to do is we're going to look at our equations here, and I'm going to label them so I can know which one we're talking about. So the first one I will call A. The second one I'm going to call B. And then this one I'm going to call C. So what I want to do is I want to look and see in my equations what I'm dealing with. If you'll notice, equation C only has 2 variables. If you ever have a situation like this, where you have an equation that only has 2 variables, but you're dealing with solving for 3 variables, what you want to do then is figure out which variable is missing. In this case, the variable z is missing. And then you're going to want to cancel the z in the other 2 equations. So what that does essentially is it makes C also equation D. So C is equation D. So what I'm going to do is I'm going to take equation A and equation B, and I'm going to cancel the Z so I can find equation E. So I have x plus 2y minus 3z equals negative 13. And I have 3x minus y plus 2z equals 15. Now I'm going to want to cancel my z's. So the way we do this is I'm going to multiply both equations. The top equation, I'm going to multiply by 2. So because it's 2 down here. So multiply the top by 2. And then the bottom equation, I'm going to multiply by 3. Not negative 3, because I want them to still be opposite in the end so I can cancel the z terms. So I'm going to multiply the top, the entire equation by 2. So that gives me 2x plus 4y minus 6z equals negative 26. On the bottom, I'm going to do distributive property, so 3 times 3 and so on. So I will multiply everything in that parenthesis by 3. So I'm looking at 9x minus 3y plus 6z equals 45. All right, now I'm going to do linear combinations over here, and that will cancel the negative 6z and the positive 6z. I now have 11x plus 1y, which is y, equals negative 26 plus 45 is 19. So I'm going to call this equation E. So up here, I will do equation D, which is also equation C. So that's x plus 3y equals negative 7. And equation E, which is 11x plus y equals 19. On this one, I think it's going to be easier to cancel the y's. So I want my y's to be the opposite of each other. So I'm going to multiply the bottom equation by negative 3. So I get negative 33x minus 3y equals negative 57. All right, now I'm going to bring my D equation down here. So that is x plus 3y equals negative 7. Cross off those cancel, and now I'm looking at negative 33x plus 1x. Well, that's negative 32x equals, well, negative 57 minus 7 is negative 64. Okay, now I divide both sides by negative 32. That cancels, and I'm left with x is equal to positive 2. All right, so I know the value of x, and now I need to find y. Well, if you see down here in your E equation, the y is just a 1y, so that's a really good place to plug it in. So I'm going to plug this value for x into this equation. So I have 11 times 2 plus y equals 19. Well, 11 times 2 is 22 plus y equals 19. I'm going to subtract 22 on both sides. So y equals negative 3. All right, I have my x value and my y value. Now I want to find the z value. So I'm going to plug that into the first equation right here, equation A, to solve for z. Okay? So x is 2, so I'll rewrite this as 2 plus 2 times negative 3 minus 3z equals negative 13. So 2 minus 6 minus 3z equals negative 13. 2 minus 6 is negative 4 minus 3z equals negative 13. Now I'm going to add 4 on both sides, which is negative 9. Then I'm going to divide negative 3 on both sides. So z equals 3. So x is 2, y is negative 3, and z is 3. So our ordered triple, so our answer is 2, negative 3, 3. And I would recommend plugging these in for x, y, and z into the 3 equations just to check to make sure that they work. But for now, your final answer for solving systems of equations in 3 variables is 2, negative 3, 3.